3 right now, and we're going to combine it and also do question, because we skipped a question from 7.3. We'll do that one as well. So chapter 6 was a lot about solving equations. Chapter 7 does it again. But what chapter 7 also introduces is solving with identities. Now this question we did in chapter 6. The only difference is in chapter 6 I gave you a hint. In chapter 7 the hint goes away. So in chapter 6 you would have got a hint that said use your big idea, sine squared plus cos squared equals 1. Because initially when we go to solve this, it has cos and it has sine, which makes it impossible to factor or quadratic formula or anything. However, we can now rewrite this and go, because of the big identity, or the big idea, I can change the sine squared to 1 minus cos squared. And now I've changed the equation just to have cos. If I distribute my 2, can you see that I would get positive 2 cos squared? I always like to write my cos squared first. I still have minus 3 cos x. And here I would have 3 minus 2, which will be plus 1, equals 0. At this point, it's quadratic. You could use quadratic formula, or maybe you recognize this one factors nicely. The only way to get 2 cos squared would be 2 cos x and cos x. The only way to get 1 would be 1 and 1. I need my outside and inside to make negative 3, so they would both have to be negative. And now we've changed it from adding to equal 0 to multiplying to equal 0. It's the big powerful thing. Because if you have 2 things multiplied to equal 0, either this one is 0, in which case cos would have to equal positive 1/2. Or this one is 0, in which case cos would have to equal 1. And on your chapter 7 test, you'd have your pi plate. So you'd be like, ooh, when is my x coordinate 1? At 0 and 2 pi. And when is my x coordinate equal to 1/2? It's my power of a 3 family, quadrant 1 and quadrant 4. Okay? And I just solved between 0 and 2 pi. And now I should reread my question. Did my question say between 0 and 2 pi? No. My question only went up to 3 pi over 2. So what does that mean? I have to take out the ones in quadrant 4. So I have to take out this one, and I have to take out this one. And my only answers are 0 and pi over 3. Sometimes you read it again and find out, oh, it was a general solution. You'd have to go plus 2k pi to each of your answers. Circle question 10, but I also wanted to do the questions we skipped from 7.3. So I'll get you to turn back to 7.3 on page 610. Because we skipped number 3 on 610, right? Yeah. So it's another solving one. So it seems like a good time to go into another solving question. And don't throw away your identities sheet because we do the back is all solving with identities later on. So we want to solve each of these. So again, it becomes really important that you read a question, because I've had students get a solve question and try to prove it, right? Or a prove question and try to solve it. They're different. Proving is when they're always going to be the same. Solving is finding the specific times that they're the same. So in this first question, we run into a problem because we want to solve, but we have a sine and we have a cosecant. They're not the same trig function. But if there was a way that we could change everything to have the same trig function, maybe that would help. And I hope you recognize that you could change the cosecant to 1 over sine. Does that 2 go to the bottom? No, it does not, because it is 2 over 1. So we have 2 sine x equals 3 plus 2 over sine x. If you have a question where what you want to solve for, we would like to get sine x by itself, and you have one in a denominator. This is an equation. How could I get rid of that in the denominator? Multiply by sine, right? So if I multiply this side by sine, I would multiply this side by sine as well. Which means everything gets multiplied by sine. So you'll see that sometimes maybe you do this, or teachers like, oh, just multiply every term by sine. But the reason you're multiplying every term by sine is because you're multiplying this whole side by sine. Put it in brackets, multiply by sine. That would multiply the 3 and multiply the 2 over sine. So what do I get? When I multiply this side by sine, I don't get 3 sines, I would get 2 sine squared x. And when I multiply these ones, I would have 3 sine x. And here, the reason we multiply by sine is so they cancel out, it's just plus 2. Which is a quadratic equation. Move everything over to one side, so you have something equal to 0. Hopefully you're getting good at factoring. Has to be 2 sine x and sine x. We need the outside and the inside to make 3. So I would need my outside here to be 2 to make 4, and inside 1. I need a negative 3, so my 4 would have to be negative, my 1 would have to be positive. Now it's equal to 0, so either sine x equals negative a half, or sine x equals 2. Half is on your pie plate. And you see that that's your pi over 6 family, but because it's negative, quadrants 3 and quadrants 4. 2 is not on your pie plate, but we can still do this without our calculator. Pi over 2? Not pi over 2. When is your y coordinate 2 on your unit circle? None. Never. What does this mean? When I have sine x equals 2, that's like having sine x equals 2 over 1. Can you draw a triangle where the opposite side is 2 and the hypotenuse is 1? No. This side is not possible. That's why we can do it without our calculator, even though it's not on our pie plate. And at this point, I want to reread my question because I solved between 0 and 2 pi. Oh, good. It is between 0 and 2 pi. And then part B can be done in 2 different ways. Some people look at this and can just solve it because they ask themselves, there is a point on my unit circle where the x coordinate and the y coordinate are the same. It's like that root 2 over 2, root 2 over 2. So if you recognize that, that's what this is asking. When is sine equal to cos? my pi over 4 family, it's equal in quadrant 1. Is it ever equal again? Yes, where? Quadrant 3, because they're both negative. So this question could be solved just using that logic. Full marks if you did that. If you wanted to solve this one with identities, watch the following. What would happen if I divided both sides by cos? The left side would become sine x over cos x. The right side would become 1. What could I change sine x over cos x to? I can change it to tan. And now this question is asking another pi plate question. When is tan equal to 1? Pi over 4 family. It's positive in quadrant 1 and quadrant 3. So it's kind of cool that one way you solved it just using your coordinates on your unit circle, where were they the same? And the other way was solving a tan question for where it was equal. And just by coincidence, you also should do question number 10 from 7.3.